This will be a short review of ratios and proportions. First, what is a ratio? A ratio compares two quantities that have the same type of units. In this case, our example has a ratio of 8 days to 3 days. So we notice right away we're comparing days to days. There are 3 ways you'll see a ratio written. In words, 8 to 3. You can also see it expressed 8:3 or 8/3, 8/3, 8 divided by 3. In a math class, the last form, this fraction form, is most common. So that's what we'll be using throughout the video today to write ratios. One thing to note before we move on is the order of the ratio matters. So because our ratio here was expressed as 8 days to 3 days, 8 comes first and 3 comes second. Okay, so when writing ratios, it's important that they get expressed in lowest terms. So we have 2 examples to try this out. First, let's try writing the ratio of 15 hours to 60 hours in lowest terms. Right away, I'll start by writing it in our fraction form we saw just a moment ago. So 15 hours came first, 60 hours came second. And because this is a ratio, we have the same type of unit, hours on top and hours on bottom. So this really means we're reducing the fraction 15 over 60. Looks like 15 and 60 have a greatest common factor of 15. So dividing top and bottom of our fraction by 15, we arrive at a ratio in lowest terms of 1/4. So there is a 1 to 4 ratio there. As a second example, now we need to write the ratio of 20 inches to 4 feet in lowest terms. And right away this one should feel a little bit more complicated because we notice that the units of measurement are not quite the same. We have inches and we have feet. However, it's pretty easy for us to do a simple conversion. So in looking at this ratio, it's going to be easier to change my larger unit to match my smaller unit. That means I want to convert feet to inches. So if I have 4 feet, and we know that there are 12 inches in 1 foot, 12 times 4 tells me this is really equivalent to 48 inches. Now this one will proceed much like our first example. The units of measurement are now identical, and we can think about reducing 20 over 48. I'll go ahead and just use the greatest common factor again. If you like, you can just divide by whatever common factor you see. In this case, though, let's just go ahead and knock them both down by the greatest common factor of 4. And that will leave our ratio for this problem in lowest terms as 5 to 12. So we have a 5 to 12 ratio here. So now another aspect of our ratio and proportion discussion will be about rates. And it turns out a rate compares two different quantities, two quantities that have different units. So for this example, we're asked to write the rate of 300 miles in 5 hours in lowest terms. Just as with our ratios, we can express a rate in fraction form. Here it will look like 300 miles, that came first, divided by 5 hours. But notice there is no way to get rid of our units here. Miles and hours measure different things. Miles measure distance, hours measure time. So unlike a ratio, you cannot cancel out the units. But when we think about reducing, we do have 300 being divided by 5, so that gives us 60 miles per 1 hour in reduced form. And of course, we know this would be the same as what we see commonly on the roads today, 60 mph. So that's an example of writing a rate. Another great way of using rates is in finding the better buy or the best buy. A better buy if you're looking between 2 items, and a best buy if you have more than 2 items you're comparing. This is kind of your classic grocery store application. To show an example of this, let's consider 2 options for buying tomato soup. Our first option, we can buy a 28-ounce can for $1.96, and our second option allows us to buy a 15-ounce can for 89 cents. We want to know which one would have the lesser cost per 1 ounce. So, just like I said in words, cost per ounce, we need to carry out some dividing here. If I take the cost of our first option and divide it by the size, this turns out that $1.96 divided by 28 ounces would be costing 7 cents per 1 ounce. I could put a little 1 there if you like. In the grocery stores you'll often see this written. Of course I can write it kind of sideways as 7 cents per ounce. And if we carry out that same idea for the second option, we should be able to tell which one has the lesser cost per 1 ounce. So we're basically finding a unit rate here. When we take 89 cents and divide it by our 15 ounces, this one will require a little bit of rounding. I'll round to the nearest cent, so it's about 6 cents per 1 ounce. You can check that calculation. And so I'll just go ahead and write it again kind of sideways like you might see it on a grocery store tag. So if I asked which is the better buy here, we're going to say option 2 is definitely a slightly better buy because you're paying 6 cents per 1 ounce rather than 7 cents per 1 ounce. So that's a great application of rates. Now our last part of this video we'll talk about the proportion aspect. So what's a proportion? A proportion is basically just two ratios set equal to each other or two rates set equal to each other. So let's try writing a proportion. Let's write $30 is to 2 hours as $60 is to 4 hours as a proportion. We were just given it in words. If we write it in our fraction form that's most commonly used in a math class, it will look like 30 is to 2 as 60 is to 4. So that would be kind of the fraction way of writing that proportion. Just to make sure we're clear, there was another way of writing ratios using a colon. You can also use that here with proportions, so I'll note this down on the bottom here. You could see this proportion expressed 30 is to 2 just as 60 is to 4. So sometimes you'll see this getting used as another way to write proportions. Now how do we know if a proportion is true or false? An easy way to tell is by using an idea called the cross products. So I have a new proportion written here which says 32 is to 15 as 6 is to 8. It might be pretty easy to tell this isn't quite right, but let's justify it using cross products. So a cross product is like cross multiplying 32 times 8, and if we do 32 times 8, let's see, that'll give us 256 as that cross product. And then let's go the other way here, 15 times 16, and that'll give us 240. So in this example, because 240 does not equal 256, this means our proportion is false. And last but not least, we can also be asked to solve proportions. So let's try solving the proportion 2 is to 5 as x is to 30. So I went ahead and already set it up in our fraction form, and I have my arrows drawn like our previous example to indicate that cross products are still a strong strategy. So when we multiply here 5 times x, that'll just give us 5x. And since we're solving, we can set that equal to the other cross product. So 2 times 30, that will give us 60. And we have now a nice linear equation to solve. So since 5 is being multiplied by x, to get x alone, we'll undo multiplying by dividing. And we pretty quickly are able to find that our value of x here would be 12. You might be thinking, hey, I can solve this one by observation, which is very true. Just to note that some of you might have been noticing, how'd you get from 5 to 30? You times by 6. So 2 times 6 will give us the value of 12 for x, but not all of them are that easy to see by observation. So solving by cross multiplying is a strong strategy. And that wraps up our discussion here on ratios and proportions. So it is now time to practice. Please find the ratios and proportions practice sheet and try out a few of these problems on your own.